Hey Bram Bomber Chemistry Kids, it's Miss Morale, and today we're going to look at section 10.4 empirical and molecular formulas. So to start out, what is the percent composition of a compound? So all that is how much of an element is in a compound. So if we look at H2O, how much hydrogen by weight is in that compound of water? So we'll just write the percent by mass of each element in a compound. All right. Now make sure that you pause this video if you need to at any time, and definitely come see me on Google Meets if you have questions. This is where chemistry gets a little harder, so definitely seek out help. Number 2, describe how to find percent composition of a compound. So all that we do is we take the mass of each element. So if you want to know how much hydrogen is in there by percent, you just figure out how much hydrogen is in there by weight. And then you divide it by the total weight of the compound. So the mass of the compound. And then you just divide it by 100, or multiply it by 100 like you would any other percentage. Number 3, which information about a compound can you use to begin to determine the empirical and molecular formulas of the compound? So in order to figure that out, it's easiest to find the percent composition of a compound. So we'll go with letter C. You have determined that a compound is composed of 0.3 moles of carbon and 0.6 moles of oxygen. What must you do to determine the mole ratio of the elements in the empirical formula? So what you have to do to figure that out is you have to divide each of them by 0.3, and that tells you the ratio. So you divide by the smallest one. So you're going to divide by that. All right, next. The mole ratio of carbon to hydrogen to oxygen in a compound is 1:1. What is the empirical formula? So the empirical formula is it in its most simplified basic form. So that is easy. So just 1 mole of carbon, 2 of hydrogen, 1 of oxygen. We'll go with letter B. Number 6. You calculate the mole ratio of oxygen to aluminum in a compound to be 1.5 moles to 1. What should you do to determine the mole ratio in the empirical formula of the compound? Now, when we see we have 1.5, we know that that doesn't really work. We can't have halves. So in order to figure that out, you would have to double it. So rather than being 1.5, you would make that 3 by doubling it, and this one would become 2. So you're multiplying everything by 2. So we will multiply by 2. So we will go with letter B. What is the relationship between the molecular formula and the empirical formula of a compound? So the empirical formula is it at its most simplest form. When you multiply it by the whole number, like you would up here or by here, that's how we would get the molecular form, which actually tells us the chemical structure. So we'll go with letter C. All right, number 8. You know that the empirical formula in a compound has a molar mass of 30 grams per mole and the experimental has 60. What must you do to determine the value of N? So to figure out the value of N, like we saw in the previous problem, in order to figure that out, all that you're going to do is divide both numbers by the smallest number. So you're going to take the 60 divided by 30. So we will go with letter C. All right. You know the experimental molar mass of a compound is 3 times the molar mass of its empirical formula. So our letter N from that problem number 7 is 3. So we're just going to multiply this by 3. So that means we would have 3 N's, 3 nitrogens, and 6 oxygens. So we'll go with letter D. Now, hopefully we have time to take this last problem. This is a little larger. So sample shows these different amounts of potassium, carbon, and oxygen. Determine the empirical and molecular formulas. So this problem is the heart of what we are learning. So we'll start out with 7.89 grams of potassium. And so we have that. Now we're going to try and figure out how many moles that is. So in 1 mole of potassium, there are 39.098 grams. Now, where did that 39 come from? It just simply came from the periodic table. That's how much 1 mole weighs according to the periodic table. That's its atomic mass. So that equals, if we calculate it in our calculator, 0.2018 moles of potassium. Then we'll move on to carbon. And we are told in the problem that we have 2.42 grams of carbon. So in 1 mole, if we look at our periodic table, 1 mole of carbon contains 12.01 grams. If we calculate that out, so you could multiply that times that and divide with that, or you could just simply divide those two numbers since it's a 1. That would come to 0.2015 moles of carbon. Then let's take a look at our oxygen. So we have 9.69 grams of oxygen. And in 1 mole of oxygen, if we look at our periodic table, that weighs 15.99 grams. So these cancel out just like these did. And so that leaves us with, if we multiply that out, 0.606 moles of oxygen. Okay, so now we know how many moles we have of each one. Now our job is to write out our empirical formula. So we're going to write out K, and so we're going to take the amount that we have for K up above, and we have 0.2018, and we'll take C, and we'll write that as 0.2015, and then we'll look at oxygen and 0.606. Now we have to actually divide by the smallest one. So we saw that in the problems above, so we'll divide by the smallest one, so that's 0.2015 by 0.2015 divided by 0.2015 divided by 0.2015. Now when we do this, we're going to just round it to essentially the nearest whole number if possible. So this becomes a 1, this becomes a 1, and this is about 3. So that means that our empirical formula comes out to K, it would be a 1, but we don't write 1s, C, 1, but we don't write 1s, and O, 3. So we have that figured out, so that's great news. Now our job is to calculate the molecular formula. So in our problem up here, we're told that the molar mass of the real weight is 198.22 grams per mole. So what that means is that we are going to calculate that. So we are going to take this, and if we were to add up these amounts, so 1 potassium, 1 carbon, and 3 oxygens, we would see what our weight would be, and then we would compare that. So our molar mass of our compound from above is 198.22 grams per mole according to our problem. If we calculate it from our empirical formula, we come out with about 99 grams per mole according to that. So if we were to divide those two numbers, we would get approximately 2. So all that means that we're going to multiply our empirical formula by 2. So that means that we would get 2 potassiums, 2 carbons, and 6 oxygens, because 2 times 3 is 6. So that's our molecular formula. So that's what it actually looks like if you drew it out. All right, hope that helps, guys. Take good care, wash your hands. Thanks for watching our video. Have a great day. Miss you all.